So now we're going to transition to another reminder of current realities. As you probably know, with coronavirus, the demand for food delivery has increased, and one of the big forces behind food delivery these days is UberEats. And today we have a person who's going to be able to share some of the stories about how UberEats actually is worked on in these unfortunate times, and how he manages to keep the performance really good and make sure that you have a wonderful experience ordering your food online. So without further ado, let's transition to Kayvan, and he's going to talk about performance at a macro level.
Hello everyone and welcome to my talk. So a quick introduction of myself. I joined Uber in 2019 and I am an Android engineer on Eats mobile platform team. Since I joined, I have been working on a project called Fast Food, and the aim of this project is to lower the app startup latency of its mobile applications. And today I'm here to share with you my learnings. In today's talk, I'm going to state the problem that we were facing, talk about Project Fast Food, then spend some time on what I believe is lacking in our tech industry, and finally going to end with a few takeaways. Now, let's jump into it. The problem. They say a picture is worth 1,000 words, and if that's true, this GIF is a perfect illustration of the whole problem that each app was facing. It was super slow. But I'm glad to present that with the efforts of Project Fast Food, we reduced startup latency by more than 50%. I'm gonna give a quick rundown of the work that we did, and then I'm gonna jump into each one of those and explain further. So we always knew that there was a problem with its startup process, specifically the mobile apps startup process. But it took us a long time to dedicate efforts and energy to identify and address these issues. So the first lesson of the day has to be that performance should be the first class citizen of every app. And believe me, I know it's easier said than done, but many of these issues that we were facing would have not existed if we paid more attention early on. We needed to understand what actually is the problem, and this is not an easy question to answer. We already had performance metrics defined in our app in the form of time span events, but no one was looking at them. And if you have a metric that no one is looking, there is no point in that. So we started by analyzing those and set a baseline for our work. We took advantage of our open source tools such as Nanoscope and Jaeger to identify our bottlenecks on the client and backend, which I will share later on. We also needed to understand why these issues existed in the first place in order to prevent regressions afterward. So we questioned previous decisions that have been made from product to application and architectures, and thought about how else we can accomplish those. Needless to say that this project quickly became a high priority for us and we needed to move fast. So we were looking for any low-hanging fruits that we can grab. We did pay close attention to our API and RPC calls, the first and last mile of network layer. And we were not surprised to realize that a lot of time is being wasted waiting for content on our clients. However, our client app is very content heavy, and any reduction of content would be a trade-off. It is surprisingly motivating to see a line on a chart tick up and down on daily basis based on the work that you and your team is doing. And last but not least, we ran A/B tests and experimentation on each stage of the project that allowed us to confirm our hypothesis and also monitor any side effects that our project might have been introducing. Now I'm gonna go a little more in depth on each one of these steps. For our metrics, we have an in-house implementation of open tracing specification to measure performance spans. And to put it simply, performance spans are objects that have a start and end timestamps and a name, among many other properties. However, the difference of those timestamps give us the duration that we mostly care about. For more details on this specification, you can follow the link provided. And for our baseline and measurements, we looked at a startup latency distribution and decided to monitor P50, P75, and P90. Our goal, however, was based on improving P75. Now, that matters because the approaches and techniques we can use to improve the latency for each of these buckets can be very much different. When looking at P99, for example, you would have factors such as device model, available RAM on the device, battery charge, available storage, network connection type, geolocation, time of day, and many more factors contributing to the latency of your app. However, when looking at the mean, most of these factors get cancelled out. And that's why we targeted P75 as a middle ground for this project and would focus on different percentiles later on. Nanoscope is an open source tracing tool developed at Uber with nanosecond accuracy in traces without making the running of the app laggy in any way. So if you have done method tracing in the past and was frustrated by it, this is nothing like that. As I mentioned before, we use Nanoscope on the Android to identify startup processes and trace the method calls. We identified some non-essential tasks that we could have postponed or lazily initialized. And for the backend, we use Jaeger, another one of Uber's open source projects, which is a distributed tracing platform. And we use it to analyze the trace of our calls and identify the latency of each step of the way. We looked at the Jaeger trace for our main network call at App Startup and noticed that one of the processes starts after others and takes a long time to complete. So we started looking more into that. Then we used Charles Proxy and Postman for network call and payload analysis. Charles is a great tool for debugging and cross-team communication of issues. I love how Charles puts the network request and response and all the headers in a standard package file format that we can share across the team. And I often use Postman to run ad hoc API tests and collect measurements. We also looked at the payload that we were transferring to the client. We analyzed the necessity of each object on the payload. As is the case with any API, over the years it gets bloated with many deprecated, unused, or simply badly architected fields, and our API was not an exception. Even though we knew GraphQL is a very well defined solution for bloated APIs, integration of GraphQL into our system would have taken months, if not years, to complete. So we looked for alternative solutions. We noticed that the biggest object on this payload was our home feed content. And guess what procedure was in charge of generating that feed? If you guessed that circled procedure, you would be right. So this gave us a solid lead to follow, and that was to decouple this feed object from the rest of the payload and somehow figure out how we can reduce the latency of this service. But before moving further with this lead, there was a low-hanging fruit that we identified, and that was caching. We have a highly dynamic content, which makes it fairly hard to cache. However, I learned that first of all, the key is to come up with the right key. And secondly, you can cache anything with the right TTL. So we cache the response very close to our gateway with a short TTL. Implementing this cache gave us a significant load reduction on our services, as well as lowering the average latency of our API. Following on our lead, we started experimenting with the phase 1 of the project, which was basically taking out the feed content and making a parallel request to fetch it very early on the application's lifecycle. In the meantime, user wouldn't have to wait for the feed content in order to interact with the app. Here is a slowed down version of the experience. And after I play it, we see the splash screen and we are fetching the main content. Then, while the feed is being fetched, user would see a shimmering effect, and then the content populates. So from our experiment, we realized the effects and side effects of this change. We were confident that this change has decreased our target metric, and indeed it did. However, users did not wait for the feed to load. They started interacting with the app and started going into search instead to find their favorite restaurant. This change moved the conversion metric from the highly personalized feed to search. So that got us thinking that our goal should be to make the feed populate as soon as the app becomes interactable, which leads to the second phase of the project. There are many different ways to make the content ready for the user before they need it, such as prefetching and locally caching the content. But as mentioned before, a long-lived cache would not work for us, specifically for our use case. Here again is a slowed down version of the results of the side-by-side comparison of our control versus the result of second phase of the project. Control is on the left and phase 2 is on the right side. You see the app starts up and pretty much immediately afterward the feed is loaded. Whereas on the left side, the app takes a very long time to open with the feed. For phase 2, we took a couple of approaches. One, we classified content into different types based on the nature of the content and its underlying services. Then we returned the fastest generated content and highest priority one in the pull response. That is a fancy way of saying We separated the fastest items of the feed and the ones that had the highest importance for our users and returned them as a response of our request. That made sure we are not waiting for the whole feed generation process to finish before having a content to show. Then we split the rest of the feed into smaller chunks and send them down to the client using a predefined push channel as soon as possible. With these changes, we have already seen a significant decrease in the time span from app startup to app usable state, but right now the content of the feed was also available by the time users get there. And the result of our experiment confirmed that by showing a higher conversion rate from the feed and generally happier users. Next on our plate is a migration to gRPC and protobuf. We will also investigate the use of GraphQL for our mobile clients, and we have many proposals and ideas on how to improve our ML models and make them more efficient. Now with that, I would like to segue to what I believe is something that is lacking in our industry. But let me start with one of the key principles of computer science, abstraction. One of my favorite professors from college, Dan Garcia, defined it as the act or process of leaving out of consideration one or more properties of a complex object so as to attend to others. We are all familiar with the concept of abstraction in computer science and specifically in programming languages. However, this concept applies to way more than just computer science and programming. We can see it in company hierarchies, for example. The higher on the ladder you are, the more abstract knowledge you will have of the day-to-days of the business. And that is how it's supposed to be. But now, let's take a look at layers of our software development stack. A team is working on client features, another working on platform, and so on. Each team works on its own level of abstraction. That has many positive benefits. Everyone is an expert in their domain, and the work and responsibility of each team is siloed. However, it has some downsides as well. The full picture is blurry. The influence of engineers are limited to their domain of knowledge. You might ask, what about feature-oriented teams? What about virtual teams? And sure, those can cover some of these positions, but still, a lot of them is left out. The way I see it, our biggest gain from Project Fast Food did not come from one of these silos. It came from a team working together, expanding their domain, and having the full picture of the system in mind. A few takeaways that I would like you to remember are to expand your knowledge. Be an expert in one area, but also see the full software picture and act as an owner. I have also listed the resources that I have used here. There are many good talks on nanoscope, Jaeger, and all the other concepts that I have mentioned. So feel free to take a look at those. With that, I would like to thank you for listening.
Thank you, Kayvan. It was great to hear about the efforts that you are working on, and thank you for providing the experience that a lot of potentially even attendees are depending on unfortunate days. So we have a few minutes for questions. So let's see. Looks like so far we don't have any questions, so I'm just gonna go ahead and ask one. I'm just curious if there has been any changes to the performance efforts due to the most recent coronavirus events. Like, how did it affect your focus on reliability or performance?
Yes, for sure. First of all, thank you for having me, and it was great. I mean, I have joined this summit on previous years, and I've enjoyed it every year. So thank you for having me, and thank you for giving me the opportunity. Based on the recent events, we actually have experienced a lot of performance because, like, due to the new load of users and restaurants and the workload and the shift from our businesses, there has been a lot of issues, and I can imagine a similar thing has been going on for many of our companies. And one thing that I can say is that our regression monitoring and dashboards that we have built have been very helpful in detecting and preventing potential issues that might have come out. So those have been very good. So monitoring and regression monitoring is very critical. We have that's pretty much the only change that has happened. I mean, for example, if you think of, so one of the things that I mentioned was that our feed was the biggest object in our payload. And in the early days that UberEats app was built, the feed could have had like 10, 20 stores in the list when you would open it up for your local area. However, now that we are growing, the same architecture exists for the feed. However, number of restaurants are like 10 times more. So when we are thinking about the software that we are building, we shouldn't think like we should foresee the future and try to prevent any of those scenarios. Also, I would like to go back to what Rico mentioned. And first of all, like it was a hard act to follow after Rico, but one thing that I want to mention is that he was focused. He mentioned the monitoring and like specific measurements. Like in my experience in fast food, one of the things that I did, we had all of these aggregated numbers that our P90 is here, P50 is there, and we were imagining P90 is being occurring in, I don't know, India and some other countries that they have low bandwidth and the network and all of those. So we were blaming those features. However, I just used Postman to do an ad hoc test, and I noticed like with like 1,000 requests and with the span and timing it right so that I don't hit the limit, I noticed that, oh, P99 is even happening for me on Wi-Fi here in US. So that was not, so I questioned our assumption, and it turned out that we have different problems to solve.
Awesome, thank you. It looks like we actually have a question in the Slack channel. Unfortunately, we don't have time to answer it live. So I would really appreciate if you can address it offline. Thank you so much again for your work and for presenting this amazing content.
Thank you for having me.